In this video, we'll be looking at more examples of infinite limits. In this case, as x goes to infinity, we'll be evaluating 2x plus 5 divided by 3x squared plus 1. And once again, the rule doesn't change. We're going to simply look to the denominator and find the largest power of x in the denominator. That's the 3x squared term. And we're going to multiply by 1 divided by the largest power of x in the denominator. So we're going to multiply by 1 over x squared on both top and on bottom. We'll distribute this all the way through, giving me the limit as x goes to infinity of, if I multiply this by this, it'll be 2x divided by x squared, canceling out the x on top and only one of the x's on the bottom. So 2 over x, plus, distributed to the 5 over x squared, divided by, distributed to 3x squared, giving me 3, plus 1 over x squared. Now, if I were to again separate the limit into the division and addition pieces, it's the limit as x goes to infinity of 2 over x. And again, the only rule we have is a constant divided by x to the power of a number, and that thing is going to go to 0. So this goes to 0, plus, this one's going to go to 0, divided by 3, plus, this thing goes to 0. Now you'll notice it's extremely important for us to actually evaluate all the individual terms and write them out this way. Because if for some odd reason in the denominator we end up with a total of 0, then we were not allowed to actually evaluate the limits the way that we did. Again, we must have 0 divided by a constant such that we end up with 0. If we end up with a division by 0, then us separating this limit into all of these 4 pieces isn't actually mathematically sound based on limit properties. But in this case, this limit right here as x goes to infinity of the 2x plus 5 divided by 3x squared plus 1 is actually equal to 0. Let's look at one more example, and the example will be as x approaches infinity of 2x cubed plus 5 divided by 3x squared plus 1. Now you'll notice in this particular case, unlike the first example and this example, is that the power on top is larger this time. It's still important that we remember I'm multiplying top and bottom for every infinite limit 1 over the largest power of x in the denominator. And again, the largest power of x in the denominator is still that x squared. So when I do this, I'm now going to end up with the limit as x goes to infinity of 2x cubed divided by x squared leaves me with 2x, plus 5 over the x squared, divided by 3 plus 1 over x squared. Now, I'm going to go through, I'm going to evaluate each individual limit. The limit as x goes to infinity of 3 is 3. Now, I am starting at the bottom for a reason. As x goes to infinity of 1 over x squared is 0. The limit as x goes to infinity of 5 over x squared is 0. And then this thing right here is very unique. Again, in some cases, they would argue that this limit doesn't exist. In my case, I would argue it does exist. And this limit as x approaches infinity of 2x exists, and it's going to approach infinity. Now, it's important for us to make note that this is going to be some large number or a number that continuously increases plus 0, or infinity. And then we're going to divide that by 3 plus infinity. Now, it's bad to make this notation right here. It's extremely bad to identify that we're plugging in infinity at all. And the reason for that is technically this isn't really infinity, it's 2 times infinity because it's 2 times x. It's also inappropriate for us to make note of this because 2 times infinity is twice a number so large you can't comprehend, or it's going twice as fast towards infinity, and then it's being divided by 3. And all this really mathematically doesn't make any sense at all. Really what this is it's a constant in the denominator, and in the numerator it's increasing so rapidly it doesn't stop. And therefore the limit overall is going to be equal to a positive infinity. Make note, if this was approaching a negative infinity, then this overall top piece would approach negative infinity. And therefore this value would end up being a negative infinity. But that was what this limit approaches based on, again, using the method of multiplying both the top and the bottom by 1 divided by x to the largest power of x in the denominator.